Hi, my name is Clay and I'll be doing a brief presentation on nuclear power. The way that a nuclear reactor operates is fairly similar to the typical coal-fired power stations we use in Australia. They both heat water into pressurized steam, which then drives a turbine to produce electricity. The main difference between the two is how the water is heated. While a coal-fired power plant burns fossil fuels, a nuclear reactor produces heat through a process called nuclear fission, where one atom splits into two and releases energy. The atom usually used as fuel for nuclear reactors is an isotope of uranium called uranium-235. In a reactor, the atom is split by firing a free neutron into a uranium-235 nucleus. The nucleus will absorb the neutron, becoming unstable, splitting and releasing energy. In nature, this isotope makes up a fairly small percentage of natural uranium. The uranium samples must first be enriched so that they contain 2 to 3% more uranium-235. In a power plant, the uranium is first formed into pellets. Next, the pellets are arranged into rods, which are collected together into bundles. The bundles are submerged in water to keep them cool. Left alone, they would overheat and melt. To prevent overheating and control the reaction, control rods, made of a material that absorbs neutrons, are inserted into the bundles. The control rods are lowered into or raised out of the bundles in order to control the rate of the reaction. The rods can also be lowered completely to stop the reaction completely. When the rods undergo nuclear fission, they become hot and heat the water around them, turning it to steam, which is used to drive the turbines and produce electricity. One of the main advantages of nuclear power is that they do not depend on fossil fuels and hence do not produce a significant amount of greenhouse gases. The main disadvantage, as you probably know, is the highly radioactive nuclear waste that is produced, which takes tens of thousands of years to become safe again. This concludes my presentation on nuclear power. Thank you.